Hello, welcome everybody. Today we're just going to start with a little warm-up from what we talked about yesterday. Yesterday we talked about the amount of time it takes you to stop fully. Remember, there's two things you got to take into account. You got to take into account the reaction distance, which is the distance you travel when you just switch from the brake or from the gas to the brake. And there's also that braking distance, which is the amount of time it takes you to fully stop once you hit your brake. So in our first example, it says, what is the total stopping distance for a car driving at 35 miles per hour? So again, we first have to think about that distance we are going to go in just our reaction time, where we switch from the gas to the brake. And conservatively, we say that that is always equal to whatever our speed is. So our reaction distance is just going to be 35 feet. Plus, we always have to take into account our braking distance. And remember, we have a nice little formula for that. I'm just going to write it over here. It's always our speed in miles per hour squared divided by 20. So if I am going 35 miles per hour, I would take plus 35 squared over 20. When I just input that into my calculator, you should get 96.25 feet. So once you react, it's going to take you about 96.25 feet to come to a complete stop. What we're going to do today now is we're going to talk about accident investigation data. So we're going to look at things like skid marks and yaw marks, they're called. We're going to use those to determine how fast a car was going when they made those marks. So auto accidents happen many times. It is clear who is at fault, but that's not always the case. So we have to call in specialists to help determine who is at fault. And these specialists are called accident reconstructionists. And these, again, are people who investigate the crime scene, and they use mathematics to help them understand the circumstances surrounding the accident, which, again, would help them determine who is at fault. Reconstructionists look really closely at the marks left on the road by the car. The first mark we're going to talk about is called a skid mark. A skid mark is a mark that a tire leaves on the road when it is in locked mode. So as soon as you hit your brakes, right, as you hit your brakes super hard, your car is still going to continue forward, even though your tires are no longer spinning. It's going to leave a nice skid or a nice black line on the road. Anti-lock brakes, some cars have that, especially newer cars. They don't allow the tires to completely go into lockdown. It's more of they kind of like stop in little increments. So it locks, unlocks, locks, unlocks to help slow down. So on the right here over on this side would be an example of what the skid marks would look like for a car that has anti-lock brakes. If you notice, it's not one continuous skid mark line. Instead, it's just multiple smaller skid marks. So this would just show that the car would have anti-lock brakes, whereas the one on the left, they would not have anti-lock brakes. The next kind of mark we're going to talk about is something called a yaw mark. Y-A-W. A yaw mark is when the vehicle is slipping sideways while at the same time continuing in a forward motion. The tire marks appear curved. So if you're hitting your brakes and your wheel is turned, right, the back end of your car is still going to spin out. It's going to give you this nice curved kind of mark, or that we call it a yaw mark. So a skid mark is a nice straight mark on the road. A yaw mark is a nice curved mark on the road. And again, yaw marks happen when the car is sliding, sideways. Looking at the yaw marks and looking at the skid marks are all super important because reconstructionists can determine the speed that the car was going by just looking at those marks on the road. And a lot of times if things are presented in court, they have reconstructionists come in and they talk about their findings. They're very highly regarded. So our first formula for when we have a skid mark is given right here. It's kind of a little bit of a longer formula, but we're going to talk about what everything means. S is the speed of the car when it enters the skid. So that's what we're trying to find most of the time. D is the skid distance. So when I'm looking at on the road, all those skid marks, I'm going to measure those and find the skid distance. We'll talk about that in a little bit further detail on the next page. F is the drag factor. And the drag factor is just the pull of the road on the tires. So basically, the drier the road, the higher the drag factor. And over here, I just kind of have a little table kind of illustrating that. Right, we see on a road with ice, the drag factor is not very strong, meaning there's not a lot of pull on my tires, meaning it's harder for me to stop quickly. Same thing with, if we look at cement, apparently the drag factor is the highest, meaning I could stop much quicker on a cement road than I could, obviously, on an iced road. The next one is the braking efficiency. This is something that you would have to go to like your mechanic, and they're going to tell you how well your brakes are working. And they usually give you a percentage on that, 0 being that you have no brakes, 100% meaning that you have brand new brakes. When we're putting this into our formula, we have to make sure that we change our percentage to a decimal. So S equals the square root of 30 times my skid distance times my drag factor times my braking efficiency. Something just with the skid distance, if there's just one skid mark, you just use the length of that skid mark. However, that's not often the case. Oftentimes there's multiple skid marks. If they're all the same length, then you just use that length. However, if they are different lengths, you have to find the average of the lengths, right? To find the average, we have to add up all the skid marks and we have to divide by how many there are. So let's go ahead and jump into an example. So it says a car is traveling on an asphalt road with a drag factor of 0.78. It says the speed limit on this portion of the road is 35 miles an hour. It says the driver just had his car in the shop and had his mechanic informed him that the brakes were operating at 100% efficiency. The driver must make an emergency stop when he sees an obstruction in the road ahead of him. His car leaves 4 distinct skid marks, each 80 feet in length. What is the minimum speed the car was traveling when it entered the skid? Round your answer to the nearest tenth. Was the driver exceeding the speed limit when entering the skid? So we have to use the formula that we just saw on that last slide since we're talking about skids. So we want to find the speed of the car. So we say S equals the square root of 30 times, we just page back here, it says times D, which is my skid distance, times F, which is my drag factor, times N, which is my brake efficiency. So then at this point, I just fill in the information they gave me. So I have the square root of 30. 30 is always constant, it's always going to be 30, times D, which is my skid distance. Looks like each skid is 80 feet, so I don't have to find the average since they're all the same, so I just do times 80, times F, which is my drag factor, and it says my drag factor is a 0.78. Again, remember, the higher the drag factor, the easier it is to stop. And then times N, which is my brake efficiency. It is at 100%, right? And we want to convert it to a decimal, so we got to move the decimal place over 2 spots. So it looks like it would be 1.0 or just 1. So again, I just go ahead and I plug this into my calculator. It says we need to round to the nearest tenth. So when I do that, I believe you will get 42.3. We're always talking about miles per hour. It's the minimum speed they were going when they went into that skid. So the question is, was the driver exceeding the speed limit? Well, we gotta look, what was the speed limit? It says the speed limit was 35 miles an hour. So yes, the driver was speeding. Driver was speeding. All right, let's do one more and then, or actually, you know what? Now would probably be a good time. Why don't you pause the video and go ahead and give the next one a try. And then when you think you have it done, turn the video back on and see if you got the correct answer. All right, hopefully you had some time to read through this problem, try it on your own. Let's go ahead and check your answers. So again, we're talking about a skid, and we're trying to find that minimum speed that they were traveling to indicate or to determine if they actually were speeding. So it says, we gotta use our formula, which I wrote out right here for us, and then we just fill in what we know. So we say the speed is equal to the square root of 30 times d is my skid mark length. Here, though, we have 3 different skid marks that they have measured. Again, remember, if there's more than one and they are not the same, we have to find the average of them. So we have to add them all together. And we have to divide by how many there are, which there are 3 here. When you find the average of those skid marks, you should have gotten 71. So I'm going to go ahead and enter that for D in my formula. Times F, which is my drag factor. It looks like here my drag factor is 0.95. And then times my brake efficiency, which is at 98%, so the decimal, I'd say 0.98. So when I plug that into my calculator for speed, you should have gotten 44, the nearest tenth, 0.5 miles per hour. So if we look back at this problem, it says that the speed limit on this road is 40 miles per hour. It says that Richie says he is not speeding. The police insist that he was speeding. Who is correct? Here the police are correct because Richie is in fact speeding. He's going over the 40 miles per hour. Alrighty, at this time, this video is just about up. You will have to close out of this video and then open up the second video on Daily Planner.